Okay, so in this video, we're going to be talking about Cloudflare. We're going to be talking about D1 database and the Cloudflare workers. And I'm going to set that up. We're going to launch a Cloudflare worker. We're going to connect a D1 database, and we're going to use that as our backend for a parking app that I'm actually building, a proof of concept. So this is actually part of a broader series of videos that I'm doing, building a full proof of concept from start to finish. So if you haven't watched the other videos, please go back and watch it. We're actually going to the details around setting up a prompt and how to actually structure a prompt for coding. And then in the subsequent video, talk about getting the actual app set up and how I walk through using Bolt and Vercel to do the design. If you haven't watched those videos, go back and watch them. I'll try to link them in the description. In this video, we're going to be focusing on the backend. So the backend, where we're going to be using Cloudflare to support accepting the request from the user, in this particular case, parking pass permits. Let me level set a little bit and talk about what the app actually does, and then we'll talk about Cloudflare. We'll talk about sort of the overall infrastructure that we're setting up. I have here a basic diagram to highlight what we're building. We have this notion of a user that's in a condo building. There's a parking enforcement app is what I'm building, but there's actually 3 separate components to it. So a user is sitting in a building and they have the ability to sort of order a parking pass for a car. This might be a visitor or somebody that's, just showing up at their building or whatever, and they just need a pass to validate that their license plate is authorized to park in that building. And they're going to visit a website. That website, they'll be able to put in their name, phone number, email address, etc. And that will allow them to request a parking permit. Now, when they do that, it's going to be stored in the Cloudflare D1 database. We'll talk about what a D1 database is if you don't know what it is. In order to do that, we need to put a Cloudflare worker. So we're going to put W for worker here and D1 for database. Basically, the app is a Knox-3 app, and X3, I don't have my pen. So it's a Knox-3 app, right? So Knox-3 app is going to talk to the Cloudflare worker. The worker is basically going to talk to the D1. It's going to get the results, bring it back to the Cloudflare worker, return it back to the app. Pretty straightforward client-server type of technology, except that we're doing it on Cloudflare, which means that it's at scale already. So that's basically what we're going to be doing. Now, the other parts to the app that I just want to highlight that is also important is the fact that we have a parking enforcement person, and they need to be able to come in and pull up their app, and they need to be able to enter the license plate number, which will then obviously go look that up in the D1 database. Once they do that, they'll be able to then decide if they need to issue a parking pass, a ticket, or they need to give them a pass and say, yeah, you're valid. And if they do issue a ticket, they need to log that information as well. And that's also going to be logged into the D1 database. And then on the backend side, the office manager or the owner of the company will also have access to that D1 database, and they will be able to see a list of all the parking tickets that were issued for one or more buildings. And then they'll be able to do a report. So that's what we're building. That's a recap just to give some context. Please watch the original video of the vibe coding, how I went through the thought process of getting the SDR, just the overall concept in place. I talk a lot about the concepts there. So again, not to sound like a broken record here, or go watch that video. So let's talk about Cloudflare and D1 and what is it. D1 is an SQLite database. So essentially what the SQLite database is, a file system database. They're doing some fancy magic at the back to make it scale. But essentially what happens is you have a worker, Cloudflare worker, and it kind of sits pretty close, if not on top of the D1 database in the same unit. At least that's what I'm understanding so far. And then that means that you have the database very, very close proximity to the worker, which means that it's very fast in terms of accessing data. I think they're kind of moving around this database. They have some sort of extra storage system. This is my general understanding of what they're doing. And then they move this database based on how you set up your data structure. There's multiple of these databases, and they want you to use what we call like high cardinality, something extremely unique to the user or the tenant or whatever it is, so that for every single user, it's kind of spinning up one of these databases, and therefore you could get massive scale because one of these databases can only store up to 10 gigabytes of record, and what they want to do is allow you to spread that out across multiple different databases. My understanding is that it's also extremely resilient in the fact that whenever you write to that database, it gets replicated to 5 different regions automatically. Only after those 5 reads or write actually happens, then it actually confirms that, yeah, you're good to go. Data has been successfully written. So it's highly resilient based on my understanding. So it's an interesting platform. That being said, it's not something that I personally would do for a really large scaling application. I'd still revert to a traditional database, a Postgres database, or in my particular case, I'm a big Azure Cosmos DB fan. But this has some very, very appealing use case, definitely in the use case that I'm actually working on right now, which is this parking application. Even if there were 10,000 condos, it wouldn't get to the scale that would break this database. I was dealing with maybe 100 or so different condos. That's kind of what I'm exploring, and that's what we're going to be talking about in this video. All right, so if that's of interest to you, let's jump right into it. We're going to go set up a worker. We're going to go set up a D1 database, and then we're going to try to make them talk together. We're going to set up a schema. Okay, so with that, we're going to go back to our SDR document. And again, I've done this in the previous video, so you're going to go back and watch the video to see how we actually got this SDR document. And since there are 3 different set of apps, we're just going to be focusing on the first one. So the tenant property owner making the reservation. Here's what we're going to do. We're going to use this SDR to create an official SDR. What do I mean by that? What we're going to do is, because we're vibe coding this entire app from start to finish, okay, what we need to do is we need to be very structured in our instructions to the coding model of choice. In this particular case, I'm using VS Code. And with that, what we're going to do is we're going to use our SDR document in order to give very specific instructions for the app. So this is what the parking app look like. They'll be able to put their name, phone number, email address, etc. Press submit. That's going to go into the worker, and as I said, go to the D1 database. So what we're going to do is we're going to spin up a new GitHub repository. We're going to call it Parking App Data Store, backend database for Parking App. Okay, that's fine. All right, so clone the repository. We're going to open that up with code. Need to go one. All right, so now that we have our parking app, what we're going to do is use npm and CloudFlare to set up our database to get started. And then after this, we're just going to use AI. So we're going to create a Cloudflare D1. So we're going to call it Parking App. Sure. It's going to ask me for a framework, looking for Hello World. And then we're going to choose a worker because we're going to set up the database after the fact. We're going to choose TypeScript. And so what it's going to do is install Wrangler and put a bunch of files in this folder for us so that we have a fully working very basic app, and we're not going to deploy it. Now that we have our basic app, we're going to use Hono, I think is what it's called. Instead of using this guy here, which is sort of like the default requests, we're going to use the Hono system because it seems to be the better choice. So we're going to create an NPX. I'm going to use the Cloudflare worker plus feet, or maybe just a worker. Okay. So tell you what, this is where AI comes in. So we're going to say, okay, actually, there's one other step that I'm missing before we go too far down the rabbit hole. We need to copy this SDR. We're going to put it in because we're vibe coding all our way through this entire thing. So what we're going to do is we're going to take the SDR that I generated by ChatGPT. Again, go watch the first video so I can show you how we actually generated that SDR. And what we're going to do is we're going to create a GitHub folder and put that as the SDR instructions for Copilot. I haven't been using any of the other models. This seems to be working pretty solid for me right now. Claude 4 with a GitHub Copilot folder. So here's what we're going to do. We're going to put a new folder, GitHub, and in here, we're going to put a Copilot. So Copilot instruction file. All right. And then what we're going to do is we're going to tell Claude to generate a Copilot instructions file based on our SDR and also create a checklist, a task list file to keep track of the progress of each work and link that into the GitHub Copilot file. So let me just explain what I mean by that. So one of the best ways that really works well is you have to tell it what you're going to do, what you want to do, and then keep adding more context over time for it to stay on track. Else it just veers off track. It doesn't really know what you want because there's no memory. Okay. So this is what we want to do. We want to take our SDR, which we created initially. We're going to take that SDR, bring it down to VS Code. We're going to inject that into Claude. Get Claude to create Copilot instructions. Okay. So that Copilot instructions, we will then use based on that to then create another file called task list. And then also, if we were doing a UI thing, we would do a design document and a style guide. But we're not doing UI because we're doing all backend. So we only need these two in order to basically make sure that it works. And then as we make changes and we keep prompting the AI, so every single time we add a prompt, if there's something that we notice that it's not doing correctly, we're going to tell it to update our file. Also, as we add more instructions, we're going to tell it to make a docs folder, put special documentation in there and add it to the Copilot instructions file. This way, every single time the model starts to work on your prompt, the first thing it's going to do is read your Copilot instructions file. Then it's going to check the task list and the other reference documents. This allows it to stay very, very focused and very targeted on the mission at hand. Okay, so that's what we're going to do. We're going to use this SDR to add to my Copilot instructions file, ensure that we have all of the requirements as instructions for an AI prompt, and then also create a separate task list to keep track of all of the to-do items that we need to do to create this app, and link that into the GitHub Copilot instructions file. And every single time we complete the task, make sure that we update the task list so that we could keep track of the things that was already completed. So it's going to basically go read that Copilot instructions file. It's going to add that SDR to it, and then it's going to create a task list. Okay, so the Claude is finished creating a GitHub instructions for Copilot. It also created a task list. Now, I don't think it actually linked the Copilot document to that task list, which is okay. We're going to talk about that in a sec. So we need to link them so that the Copilot doc instructions can always reference the task list. This is the backend portion of the application. While I want to give the Copilot context, I don't want it to create, notice here it's going to create a Knox tree application, etc. What I'm going to do is change the instructions to improve the Copilot instructions to only focus on the backend and only focus on the task that focuses on the backend. This is going to be an API connected with CloudFlare D1. We're focusing on the backend implementation using CloudFlare workers and the D1 database. Upgrade the Copilot instructions to only focus on the backend portion, but also keep enough context so that we know what exactly has to be built out. And we won't be doing any authentication in this part. We're just going to be focusing on the APIs and the database portion in this particular project. Update the task list accordingly, and also ensure that the task list is linked in the Copilot instructions so that we can reference the task list and update it every single time we make changes via AI prompt. All right. So one of the things about Copilot is that it can go crazy. I'm building a proof of concept. It came up with a task list, and look at it, how long it is. Just insane, the amount of details, right? It wants to do a guest reservation system, permit management, violation management, communication, like the whole 9 yards. We're going to keep that as a to-do list so that we have that as a checklist. We're just going to tell it to just focus on the basics first, just so we could get a proof of concept up, and then we could come back and sort of build out the other features as we kind of need it. And then the other thing is, now the Copilot instructions file has the reference to the task list. This way, as we keep prompting it for more stuff, we'll be able to ensure that we have a reference of where we are in that project. Okay, so we're just going to check this in because this is a lot of files. So if you haven't know about this button here, just click on this little star. It'll automatically give you a summary of what was done. Click on commit and just click on sync. I'll go back up to your GitHub. Just a FYI tip there. Okay, let's do this. The next thing we want to do is start by creating a schema so we can create our database. We're going to start small. I'm going to create a new chat because I don't want it to take all the instructions. I want it to focus on my instructions here. Create a schema that focuses just on accepting parking requests for permits pass based on a license plate and information of the tenant. Create the schema file so that we could feed that into our script to create the D1 database. So far, we have a lot of files. We got a schema that has tenants. The tenants has email, phone number, last name, unit number, building code. It doesn't have address, so we'll need to go back and get that. Then we have vehicles. This is the vehicle information for the parking permit. So you could have a vehicle license plate, make, model, etc. Then you have permit types. These are the different types of permits that you could request. It's a parking pass, so don't necessarily need the permits type table, but sure. And then parking and a permit request, which will have the reference to the tenant and vehicle. And then you have a permit type ID and all the other stuff related to the permit itself. Now you got approved permits, some permit table for approved permits. So this is the approved permits. That's fine. We're going to do it this way. We're going to just let it kind of do its thing. So this was a lot of tables, but we got some basic structure. So now let's just get it to create the database. We're going to let it create the D1 database in CloudFlare. And then we're going to create a Hano app to basically access that database. Let's run the script to create the D1 database in CloudFlare and also create the Hano application to submit permits and read those permits by the license plate number. Check this in. Okay, so the good thing about Claude is that it's actually going to try and run some script. Now we noticed that it couldn't find the database name in my Wrangler file. So it's going to try and actually create that Wrangler file, which is fantastic, right? So this is the Wrangler file. It's going to put the parking permits thing and then run the script again. See Wrangler execute D1 parking permits. And then it's going to pass in the SQL file. So it's going to create all this stuff, right? So we have a full database schema created. Our database is called parking permits DB. Let's go. We're going to go back to the CloudFlare and we'll look for that database. There we go. We got our parking permit database. We got nothing inside of it. No tables. No nothing. So we've created the Hano project. It's quite a few moving parts. It's still running into some build areas, but we'll just talk about it in the meantime. We're importing Hano. It's dealing with cores, so cross-origin request resource script to ensure that we'll only accept our requests from very specific URLs. It's using middleware, which means that whenever the request comes in, it's going to stop it, check it, says, yes, are you coming from the right resource? And then it's going to continue. This is not security like authentication. Just want to be clear with that. This is just to just make sure that when the browser sends a request, that we only accept requests from a very specific URL. This app needs to go through some sort of authentication if it's going to go out on if there's some sort of login system, right? Right now it's a public app, so anybody could send in a request. But if it were to be a public app, we should put some sort of security in place to ensure that it's a little bit more locked down by using some sort of authentication provider, etc. One way that I'm going to somewhat solve that problem, it's not a full security implementation, but it will help to kind of mitigate some things, is we're going to put in our Nox application on our front-end application. So we're going to put a environment variable, and that environment variable at least will help to, so we're going to put, let's just make it clear. So this is our NAP, and this is our worker, and this is our D1 database. Okay. So what we're going to do is we're going to put an environment variable in CloudFlare, env, and it's going to be some sort of code. And we're going to put that same env in here on the back end. And basically what we're going to do is every time we send a request, we're just going to check for that code. We're going to send it across the wire, and then we're going to check for that code on this side. It's not a foolproof system. It's just something to just add a little bit of thing. It's not a full security implementation. And then of course we have the cores to just ensure that we're only getting a request from this thing. Again, this is a proof of concept application, so we're not going to go into full security. To do this right, you need some sort of authentication server so that this could validate against that authentication server, get a token, and then send a request here. And then this could go back to the authentication server, validate that that token is actually valid before it serves the request. That's outside of the scope of this conversation, so we're just going to pretend like we have proper security. Okay, so while it's actually going through and doing a check, what else do we have in here? We got our cores, we talked about that. It's doing a login, so it has a logger. And then we got a tenant. This will allow us to create a tenant. One of the problems that I have though is on the front end, I'm just going to be sending a very basic form. That being said though, there are reasons for doing this, having sort of a separate tenant database. So what I'm going to do, I'm going to show you how I'm going to get around this problem, because I don't necessarily want to have to hit all of these endpoints in order to create a parking request permit. And then there's also one other problem, which is that the tenant is using an ID system. The problem with that is that the ID is unique, but this is a public facing website. One of the issues you're going to run into is, for example, if I have a user that comes to visit the website. So we got our user here. I'm just using out of color. Come on. So this is our user, right? Come to hit the public website. They're going to fill in their form with their details and email address. And then that's going to send it to the backend and create a new ID. Okay. We're going to store that into the database as a tenant. We're also going to register their vehicle and then issue them a permit. So we're basically going to be doing 3 separate actions in the backend. This is so that we can separate the data later on. The problem is that if the user comes back to the site, let's say in a month's time, and they submit that information again, theoretically speaking, it's going to generate a new, okay? So we need a way to map this public facing user to the same ID to say, we already have your information. So we're not going to create a new record for you. We'll just create a new permit. And so the only way to do that would make sense is if they use the same email address. In this particular case, we're going to tie the user or the tenant to the email address. And whenever they do a submission, we're going to use that submission to create a unique ID, and then we're going to store that in the database. Now, this is a NoSQL database, so it's using, I think, a number system for the ID. We might have to actually create a unique tenant ID separately to hash that email address and make it a lookup. We'll talk about that in a bit, but I'm just bringing that to your attention. All right, we got our database, we got our Wrangler set up, and what we're going to do is run a basic version to make sure it's working properly. So how are we going to test this? The best way that we can test this is a couple of things. Number one is I want to make sure that it's doing the right thing from day one. We're going to hash in the user to make it a unique ID and let it make those changes right away. Okay, so what we want to do is we want to ensure that the backend is adhering to this simple form. If you notice, it's a very simple form. So I'm going to give it this as the screenshot. Okay, I want the API to only support this. I don't care what complexity you have in the backend to store the data. I just care that this is the interface that the user gets to see. So the way I'm going to structure that is, number one, I'm going to paste the prompt here. We're going to go to this file here and paste that image in, and then use the image as a reference to create a centralized API, one API that when submit will automatically in the backend create the tenant, create the vehicle, create the permits. We also need to ensure we're keeping the address for the tenant. And once you're finished, create a HTTP file with dummy data so we can test the entire thing and make sure that it's actually submitting to the D1 database. So I'm expecting that it's going to make one change. It's also going to give me a centralized unique endpoint. But I already noticed that we didn't have a full address inside of there. So it's going to put that address in the schema for the tenant. And then it's going to do the updates to the D1 database. I don't even know how to do a database migration on the D1 schema, but that's why we have AI, right? So it's going to upgrade the schema with that full address, and then it should run the migration. Now we also did a change here. It says centralized permit input, right? So in other words, it's created a new type that we can use. So it's going to create a new type that's going to take first name, last name, email address, phone number, unit, number, building code, full address, license plate, make, number, year, province, which is part of the address, country, that's going to be defaulted, right? Permit type, which is going to be optional, start date, end date, notes, priority, etc. So that's basically the model for this form. And then once it receives that data and it submits it, let's see where it's putting it. So we're going to it's going to come to this endpoint. It's going to submit it to this API endpoint, submit permit request. It's going to take this as a type, and then it's going to basically do all of the other things underneath the covers, which is to take the tenant, check if the tenant equals, select ID from tenant where email address is true. So it is using the email address. Check if the tenant exists. It's using the email address as the tenant ID, which is fantastic. If tenant exists, then it will update the phone number and details if it's different. Otherwise, it's just going to continue on and create a new tenant if they don't exist. Then it's going to continue on, update vehicle information if exists, otherwise create a new one. So now it created a database migration script to add full address to the SQL, and then it's going to update the schema. Again, all SQL stuff that we don't have to. It seems to be stuck in a loop where it's trying to find the Wrangler file, but I have a Wrangler JSON C and then I have a Wrangler TOML file much inside of it. So the truth is I actually don't know the difference between, because I think that they're actually the same file. I'm pretty certain of that. So what I need to do is I need to just tell it to use one of them. C2 ED67 2E. Yes, it's the exact same thing. So we just need to tell it. My understanding is that the Wrangler.toml file was the original, and then they did the JSON C. So that's what happened. It should be better now because it was kind of missing this entry point to the assets folder. Okay, so interestingly enough, this was spinning for a while and it keeps going around in circles trying to figure out how to deal with this Wrangler file. It tried to do a JSON C, then it basically, we got rid of the TOML file. Then it just keeps going around in circles. So now we have a JSON file and it got rid of the comments because it wasn't working. But every time it runs, it keeps saying that it's missing the entry point for worker script, even though it's specified here, source main index.ts, which is basically this guy here, right? That has all of the file details for the implementation. So that's something that I haven't seen before. I'm going to try to figure out what to do with it. So first of all, one thing I would always recommend is you get to a certain place in your code, just make sure you do a commit. Make a change, commit. Like just small bytes, coding could go off rails very fast. So what we're going to do is I'm going to clear this, go back here, click in this file. I'll paste. Well, first we need to clear all of these. Every time Copilot just keeps adding more and more terminals. Hasn't figured out how to just use one terminal as yet. So we're going to paste this in there and then let it kind of figure out what to do, and then we'll see what happens. All right. So it was finally able to figure out how to actually run the project, and what it boils down to is that the working directory and where my code is in two different things. So you see here, because we're in a subfolder, the Wrangler file is here, and I think we're running on the root level. There's just some inconsistencies with how the project was set up. Nonetheless, we got it working. To prevent this problem from happening again, I'm going to ensure that you add this to the documentation. This is one of those things about ensuring that whenever you solve a problem, you add it to the instructions. In this particular case, we need to label it as important so we don't run into the same issue again. Add this to the Copilot instructions so that we mark it as important so that we don't run into the same issue again in the future. Okay, so we're going to do a test now. We're going to try to see if we can get this submission to happen. So what we're going to do is we're going to go to our local folder. We'll do npm run dev or Wrangler dev. Let's do Wrangler. And then that's going to spin up the server so that we're listening on this particular port. And it has a mapping to the database, to the Wrangler database. So in theory, if we click on this button here, this is our HTTP file that it created for us with some dummy data. If I click submit, we should get something. Oh, looks like we got an error. What do we see in here? Centralized database, no tenant name, full address. I think we didn't run the migration script. That's basically what happened here. So we need to get the migration script running. So let's copy this and just tell this bad boy. So this add basically needs to run this add address SQL, which is this guy here. But I don't want to do it. The truth is I don't even know how to do it. So it's going to run this Wrangler D1 execute DB with local add migration. If you do Wrangler D1 execute and you specify the actual schema, it'll do it correctly. So it's going to run the test again, an error. So submit permit is still failing for some reason. Okay, so let's go to our database and see if we could actually see some data. / tables, show a list of tables. This query successfully executed, respond. Where are my tables? I actually don't know SQLite. Can I not? Is there no UI that I can click on? Export my data. I think it's running on a local database. So let's tell it to deploy to the cloud. Let me double check that this is working. We're going to go back to HTTP and submit this. Connection rejected. We need to do Wrangler dev again. Back in here, do submission, internal error. Okay, so we got another SQL error. Okay, so that error was basically due to the fact that there was some constraint on a very specific request number. It says that it was null. So these are just like very primitive errors that it's one of the reasons why I actually prefer a NoSQL database system, but for this particular case, it actually makes sense to use this. Let me see if I can run that again. Okay, we're getting a response, but it's still going actually. We should be able to test this now. So let's do Wrangler dev and then send here, internal error again. Interesting. So we've still got an error there. Okay, so most of these errors were pretty basic. They were just auto generation errors. So permit number was not being generated. And now it's generated because there's some constraint on what the SQL schema requires. So we're going to do that. We're going to commit this code since we know that it's working. Just for the sake of my sanity, we're going to do one last test. There we go. Fantastic. Create. Perfect. We now have a proper database. Now, the truth is, this is not, I think this is just running in D1 database locally. It's actually not going up to the cloud. We need to do Wrangler deploy. There we go. We got data in here. Let's see. Explore. Interestingly, I don't know how to see the data, or maybe that was from my request. I'm not certain. So it was a little bit confusing. I think the D1 database is running locally right now. So let's just tell it to do a Wrangler deploy. Let's see. Okay, so this is all good. So let's just go back here just to give it a foundation and say, how do I deploy this? How do I deploy this database and test it in production? So I think you have to do Wrangler deploy, but we're just going to let the AI figure that out for us. After a little toiling, we were able to run. So the first command that you need to run is basically, see Wrangler. So they did a Wrangler, where is it? Here. So he did a Wrangler info to get the info from the database, D1 info to get the info. Then he did a Wrangler execute this particular database and then pass the schema. But it turns out that when you do that, it just runs it locally, which is why we couldn't see that schema online. We had to pass in the remote flag to get that going up to CloudFlare. Then there was just this request number thing, which I should add instructions to tell it to make sure that we always have that request thing, but I'm just going to skip over that for now. So we actually got a URL for the worker. Let's just go up to Cloudflare and just double check that that's actually in the right place. So now this would make it more sense. If I go back here to refresh, there we go. We got tables. And if we go to permits, generate request number, not certain what these are, but let's go to permits. Interesting. Active permits there. Not know what these are. So these are the tables. Maybe these are the changes or logs or something. Yeah. So you just got to double click on the actual table itself. So we got permits, we got vehicles, and we have requests. The last thing we're going to do here is double check that the actual Cloudflare API is working. We're going to try that from Postman just to not be inside the cloud ecosystem, the Cloudflare ecosystem, and see what happens. So D1 workers, and we're going to go to parking permits API. And in theory, if I go to this bind here, I go to settings, I copy this URL, and I go to Postman, and let's create a new workspace. So we're just going to create a new blank workspace, and we're going to give it a name. Okay, there's a blank workspace. We're going to call it CloudFlare. Click on members, collection, request permit. Then we're going to go back to get the actual URL. Got the wrong Visual Studio. Go back to this guy. We're going to copy that. Go here. We want to change it to a post, and we want it to JSON. And we're going to go to body, raw, go between brown. Okay, we're going to go with that for now. And let's just put a new license plate here. So Dwayne D1. All right. Submit. Invalid license plate format. Oh, that's interesting. It's validating my license plate format. There we go. Created. Fantastic. Let's just go double check what that looks like out in D1. And now we have an API that can actually take requests and save it to a database. And we're good to go. Let's go back here and do a refresh. Parking request. There we go. We got a request that came in. It was a temporary request for permit request. Where is it? Let's just go with permits. So here, click on refresh again. There was a guest vehicle ID. Let's go with vehicles. I'm just trying to double D1. There we go. Okay, so D1 Honda Civic. And this was the tenant. So B6F, whatever. And we got B6 Dwayne Brown. Email Dwayne Brown. Fantastic. Perfect. Okay, so we now have a successful API that allows us to basically process data going straight into Cloudflare. And now with that, we can go back to our notes very quickly. I may have lost the notes, but anyway. So the bottom line is that what we're doing now is, now that we can push data to a D1 database with a Cloudflare worker, we can set up our parking enforcement app to double check. That app will look the license plate up to double check if it was issued before, if it has a active parking permit. And if it does, then nothing to do there. Or it could issue a ticket. We're going to build out a little bit more, and then we're going to build a dashboard on the back end to see all of these in action. This has been a longer video than I was hoping to do, but I just want to complete this entire thing. Hopefully you got some value out of this. And if you did, please like and subscribe, and have a wonderful day.